Okay, so we're going to look at how to convert from one coordinate system to the other. So the relationship we know that they have is that the origin of our rectangular coordinates is the same as what we call the pole, where the angle vertex is, in our polar coordinates. And then the x-axis in the rectangular coordinates is the same as the polar axis in polar coordinates. The way that we can convert this is if we take, since we know that the cosine of theta is equal to x over the radius, right? And if we solve that for x, we get x is equal to r times the cosine of theta, and y is equal to r times the cosine of theta. So we'll see how this works depending on what quadrant the point of rectangular coordinates lies in. Okay, so we just discussed how since the sine of theta is equal to y over the radius, and the cosine of theta is equal to x over the radius. When we solve this for x, we get x is equal to r cosine theta. Solve this for y. Let's multiply both sides by r, and we get that y is equal to r sine theta. Okay, so what we're going to do is use this formula to find the rectangular coordinates of these two polar coordinate points. Okay, so for A, let's get our x point first. That's going to be the r part, which is 6, times the cosine of the angular part, which is pi over 6. And the cosine of pi over 6 is equal to the square root of 3 over 2. So we're taking 6 times the square root of 3 over 2. So 3 times the square root of 3 is the x component. And then the y part is going to be 6 times the sine of pi over 6. So the sine of pi over 6 is 1/2. So that's 3. Okay, so the Cartesian, or the rectangular, for A is going to be 3 times the square root of 3 is the x component, and 3 is the y component. Now in a rectangular coordinate, that lands in quadrant 1 because they're both positive. And then pi over 6, the angle is within quadrant 1, and the direction is positive. So this syncs up with our thinking about that. Now here I've got both parts negative, so this will be interesting, right? So in this case, we've got an r of a -4, and we've got a theta of -pi over 4. Okay, so let's just think about that to begin with. If we were doing this, -pi over 4 takes me down here in quadrant 4, but I'm not going in the same direction, I'm going in the opposite direction, so it's going to put me up here in quadrant 2. So we should expect a negative x, so x should be less than 0, but y should be greater than 0 as we calculate this out. So let's calculate x. It's going to be the -4 times the cosine of -pi over 4. Okay, and if we remember the even odd properties, when we have a cosine of negative theta, it's equivalent to cosine of theta, right? So this is going to be equal to -4 times cosine of pi over 4, which is the same as cosine of -pi over 4. They're both going to be square root of 2 over 2. So that simplifies for x to -2 times the square root of 2. Now for the y part, so that takes us back here. Now we expect to get y, -4 times the sine of -pi over 4. And remember that a sine of a negative theta was equivalent to the negative sine of theta. So the sine of negative pi over 4 is going to be a negative square root of 2 over 2. So this will be equal to negative 4 times negative square root of 2 over 2. So I've got a negative times a negative, so I've got a positive 2 square root of 2. Okay, so the equivalent rectangular coordinate, this is the polar, and it matches up with the rectangular where x is negative 2 square root of 2 and y is positive 2 square root of 2. And as an xy pair, that puts us in negative direction for x, positive direction for y. Right back into the quadrant 2 like we found with the polar variety.